This video is entitled Relationships Between Entities in a Conceptual Data Model, Chapter 3 of Introduction to Database Systems Modeling and Administration. I'm Dr. Reneau, and I'll be taking you through this brief video. In this video, we're going to talk about relationships between entities. We're going to talk about them in the conceptual data model and how they're drawn. We're going to talk about relationships that are unary, binary, and ternary, which are one entity to itself, one entity to another entity, and three entities related to each other. We're going to talk about the cardinality of relationships, which is how many times there's a repeat on one side or either side of the entities of the relationship. And then we'll talk about specialization and generalization of entities, which is a special type of relationship in the conceptual data model. Let's define a term, and the term I want to define is arity. And arity is the count of the number of values or entities in a relationship. In a conceptual data model, there are three common types of relationships. There's a binary relationship. Binary means two, so that's where one table relates to another as well, let's say uh, an automobile is or a vehicle is owned by a person owns many vehicles. So there's a relationship between people and vehicles. There's a unary relationship, and unary means one, where a table relates back to itself. For instance, maybe you have customers and you have a customer that's referred by another customer. So the referral is between one customer and another customer, and it's one entity relating back to the same entity. And then a ternary or three-way relationship are where three entities relate to each other. Now, we can have relationships with four or five or six entities, but if we understand binary, unary, and ternary relationships between entities, then generalizing to n relationships is easy. And really, you're going to see as we move forward, all relationships are going to be eventually reduced to either unary or binary relationships because those are the only kind of relationships we can actually build in a database, relational database at least. So let's look at a binary relationship. Yeah, over here. So in this diagram, we can see the two entities of machines and parts, and we can see that they're related together. In the conceptual data model using the ORM2 notation, which is the notation we'll be using to talk about conceptual data models, there's a rectangle in the middle divided into two, and there are words that describe the relationship. A machine contains parts, and parts are in machines. Now, this is a simple relationship, but you can see that a machine is made of parts, and parts are used to build machines. Now, you could have used different words, but that as long as they're clean and meaningful and make sense, you can see how machines and parts have a relationship. Think of all the other things in your life that have binary relationships. Again, as described earlier, a car and the owner. A person can own cars, and a car is owned by somebody. Um, Pets and owners. Uh, lots of binary relationships, and we'll be seeing a lot more examples of them. Here is a unary relationship or a recursive relationship where an entity can refer to itself. Now, in this example is the example I used earlier when I was first introducing the idea of a unary relationship, and you can see that customers are referred by other customers. Now, a customer may be a customer without a referral, or a customer may be a customer and never referred anybody. but a customer could refer many other customers. So you can see that relationship. Now, here's another example of a unary relationship. Maybe a part is superseded or replaced by another part. So we would have a code saying this part has been replaced by this part, and that's a relationship between one part and another. Or an employee manages another employee, and that's a relationship on the employee entity of somebody manages somebody else. A ternary relationship is a relationship that exists between three entities. Um, and it's an entity that depends upon two other entities. For instance, in this diagram here, we can see that instead of using a rectangle in the middle with two boxes, we have a rectangle in the middle with three boxes. And I could have put names in those little boxes to describe the relationship that a customer places orders, an order is for items. So you can see that the relationship isn't directly between customer and item, even though customers buy items and items are bought by customers, but that purchase of an item by a customer is done through an order. So we can see that a customer creates an order, items are included on an order, items are on the order, and the order is for a customer. So we can see that this is kind of a three-way relationship between customers, items, and orders. Now, when we get a little further along in data modeling, we're going to reduce that into a pair of binary relationships. Actually, we're going to reduce it into a whole bunch of relationships and a couple of new entities that are missing. But we'll get into that detail as we get into more of this. Now let us define a word called cardinality, and then we'll talk about the cardinality of relationships. Cardinality is the count of entities on each side of the relationship. For instance, let's look at the binary relationship between customers and orders. A customer places an order, but an order is placed by one and only one customer. So let's look at this. A customer can place many orders, and an order is placed by one customer. And that's what that little bar here above this box says, that orders are placed by, orders have one customer. A customer can place many orders, and by the bar not being there, it represents that there can be many in the relationship. So, um, and there may be a bar over either, both, or neither side of the little relational connector here between the two. But we can easily see that an order is for one and only one customer. An order is for only one customer, and a customer can have many orders. The cardinality. Here's another example of a conceptual data model of a very simple binary relationship, again, between people and vehicles. So a vehicle is owned by one person, and a person owns many vehicles. So a vehicle is owned by one person, and a person can own many vehicles. So that's the one to many relationship between people or owners and vehicles. Generalization is another type of relationship beside the binary, unary, and ternary relationship. Generalization represents an is a relationship. And we can see in our diagram here that a customer is a person, a vendor is a person, an employee is a person, and a donor, maybe we're modeling a nonprofit, a donor is a person. So we can see that the arrow goes from the customer entity to the more generic person entity. Sometimes instead of it being called a person, it can be called an actor. It might even be called an entity, even though that could be confusing, naming your entity. Um, but Uh, you can see there. Think of all the other generalizations in your life. We could have done a generalization of vehicles, of a motorcycle is a vehicle, a car is a vehicle, a truck is a vehicle, a boat is a vehicle. So generalization. We can also use that same notation of the arrow to talk about specialization. Instead of going from the many to the one, instead of going from the many entities up to the one for the, we can do it the opposite. For instance, a doctor can be an internal medicine doctor, a general surgery doctor, a pathology doctor, a family medicine doctor. So a doctor has a specialty, and then even for general surgery, there could be a subspecialty of hand surgeon or vascular surgeon or pediatric surgeon. So the arrow goes from the specific to the more detailed, or goes from the generic, wait a minute, goes from the general to the more specific. It's drawn the same way and it works the same way, but this is called a specialization. Um, for instance, maybe you have pets specialized to dog, or pet specialized to cat, or pet specialized to horse. You could just as easily say that pet, horse, cat, dog, or horse, dog, cat, fish, bird can be generalized to pet. So you can see that they're just two different ways to look at the same thing. An is a or a has a relationship. As we talk about generalizations and specializations, we the more generic phrase used by data modelers is the phrase specialization hierarchy, meaning that there's a hierarchy of one to another level of detail. Hierarchies can be non-exclusive, so a generalization may have many specializations, and several specializations may be only one generalized entity, or an exclusive where the generalization may be only one specialization. Might be a little confusing, but let's think about it. A vehicle can't be a car and a truck and a motorcycle at the same time. It's got to be one or the other. So that would be an exclusive specialization or an exclusive generalization where, well, a pet could only be a dog, could only be a cat. So that would be exclusive. But a person could be a customer and an employee, or maybe a customer and an employee and a donor. So we can see that that would be a non exclusive specialization or generalization. If a specialization or generalization is exclusive, it can only be one, then we put a little dash line across the arrowheads and put a little circle with an X so that we can see that it's only one. So a vehicle can only be an automobile or a truck or a motorcycle. It can't be two at once. Just doesn't kind of make sense. So in this diagram, we have a little bit more detail that a person owns many vehicles. A vehicle is owned by one person, but a person could own a motorcycle or a truck or a car or multiple cars or multiple trucks or a whole combination of things. Um, but a vehicle can only be one of the subtypes. Hope this was helpful, and this concludes our video on relationships in a conceptual data model. At this point, you should be able to draw a conceptual data model given a relatively simple or even complex problem. You should be able to ferret out, you should be able to think out the entities. What are the entities? What are the things? What are the activities? Those types of the real world things that we're going to be modeling data about. And then the relationship of a binary, unary, or ternary relationship, the cardinality of that relationship as to whether it's a one-to-one or a many-to-many relationship or a one-to-many relationship. And then you should also be able to possibly see those specializations and generalizations between multiple entities. So there you go. Thank you very much for watching, and I hope to see you again in another video.